In this video, we'll talk about how to graph linear equations by plotting points and intercepts. So the technique for graphing linear equations in two variables would be, step 1, plot the points from an XY table. Step 2, we can find intercepts and plot points. Or 3, plot y-intercept and use slope to rise and run. So we'll talk about that third option in a separate video. So with our first example, we have 3x plus 4y equals negative 12, and we're given some x values already. So all we have to do is substitute the given x value into the linear equation. So the first one would be 3 times negative 4 plus 4y equals negative 12. So be careful there. There is a negative given with 12. 3 times negative 4 would be negative 12 plus 4y equals negative 12. If I add 12 to both sides of the equation now, I can see that it's eliminating on both sides, so 4y is equal to 0. When I divide by 4, I get a y value of 0. So our first ordered pair is negative 4, 0. I can come over here and plot negative 4, 0. Obviously, that's not enough information to graph that line, so we need more ordered pairs to plot. So let's try the next x value of 0. 3 times 0 plus 4y equals negative 12. 3 times 0 would be eliminated, so 4y equals negative 12. When I divide by 4, I'm going to have a y value of negative 3. So the next ordered pair is 0, negative 3. So I do have two ordered pairs plotted. I could go ahead and draw the line right now, but typically we want to find at least 3 ordered pairs to make sure they all line up in a row. It's kind of our insurance point. So the next substitution is x value of 2. 3 times 2 plus 4y equals negative 12. So that makes 6 plus 4y equals negative 12. Subtracting 6, I get 4y equals negative 18. Once I divide by 4, I'm going to have a y value of negative 18 fourths, which I could reduce each of those. They're both divisible by 2, so negative 9 halves. So as a decimal, that would be negative 4 1/2. So we'll plot that last point, positive 2 and negative 4 1/2. So you might be wondering, how do I plot something that's a half? Well, that would just be in between negative 4 and 5. So that looks pretty good. Those 3 dots do line up. So the next thing we need to do is go ahead and draw the line. So notice that I have arrows on each end of the line. That's very important. That distinguishes this as a line as opposed to a line segment that has a dot at the end indicating it stops. So when we're graphing our linear equations, most of the time we're going to be using arrows on the ends to indicate the line goes continuously in both directions. In our next example, we have y equals 3x. So that looks a little bit different from our last linear equation, but we have both variables, x and y, appearing. So again, we're just going to substitute the given x value. So we would have y equals 3 times negative 2. That means y is equal to negative 6. So the first ordered pair to plot is negative 2, negative 6. Our next substitution, x value is 0. So y would equal 3 times 0. That means y is equal to 0. 0, 0. Well, you remember that's the origin. So although that's enough information to see the line, we want one more point for insurance purposes. So y now equals 3 times 1. Y value is 3. So we'll plot 1, 3. 1 for x, 3 positive for y. And sure enough, those 3 dots are lining up. So we want to graph our linear equation using arrows, and there is our straight line. So notice that if you have y equals 3x and you don't have any other constant term, remember y equals mx plus b for the slope-intercept form. B indicates the y-intercept, or where the line crosses the y-axis. So if we have no number written, that's really the same as plus 0. And sure enough, our line does go through the origin at a y value of 0. Now this example is a little bit different than the other two. Y equals 4. Notice that there is not any x in the linear equation. So how could we possibly substitute something for x if there is no x? Well, that's because this is a special case. Y equals 4 means the y value is always going to be 4, no matter what the x value is. So you can choose any value you want for x. I could use 0, I could use -3, I could use +5. And now I could plot those ordered pairs. 0, 4, -3, 4, and 5, 4. Notice what kind of special line this is going to be. It's going to be a horizontal line. We also need to include arrows on both ends. So this line is y equals +4. So no matter where we go on this line, notice the y value is always +4. In our last example, we have x equals -5. So this time we notice we don't have the variable y in the equation. So x is always worth -5. Y could be any real number. So I just randomly chose some values. Let's make this a +3 just to have some positive and negative numbers. So plotting -5, 0, -5, -2, and -5, +3, you can notice that this special line is a vertical line. Again, we're using arrows on each end of the line. No matter where we go on the vertical line, the x value will always be -5. So this equation, x equals -5, results in a vertical line. To explore the intercepts of an equation, we're simply looking for the ordered pairs where the graph crosses either the x-axis or the y-axis. So in our first example, we can see that it's already labeled y-intercept is at 0, +6, and our x-intercept is at -4, 0. In our second graph, we have an upside down parabola. So it doesn't really matter what the shape is, the graph could cross the x or y axis. So notice with the parabola, we've got 2 different locations where our graph is crossing the x-axis. So at -1, 0 and +3, 0, so we have 2 x-intercepts. And up here at 0, 3 is the y-intercept. So there's only one location for where this parabola crosses our y-axis. In graph number 3, we have a horizontal line. And notice this horizontal line, this particular one, will never touch the x-axis because they're parallel to each other. So we have no x-intercept, but the y-intercept is going to be at 0, -2. And only that one ordered pair. For the last graph, number 4, we have a vertical line given. It's crossing the x-axis at -3, so the x-intercept would be at -3, 0. And notice I'm not just writing -3, I'm writing the intercept as an ordered pair. Do we have a y-intercept? Does this particular vertical line ever touch the y-axis? And that would be no, it's running parallel to it. So in this case, we have none. So would there ever be a time that a vertical line has an x-intercept and a y-intercept? Well, that would be the actual y-axis itself. So if I drew a vertical line right here, I would have an x-intercept at 0 and a y-intercept at 0. The same would happen with the horizontal line. The only time I would have both an x and a y-intercept is if the actual horizontal line was the x-axis. So we have to think carefully about that situation. In order to graph linear equations in two variables by finding intercepts, we specifically want to substitute 0 for x and 0 for y, and that will calculate our intercept. So there's no guessing by looking at the graph. We calculate it. So when we substitute 0 for x, 2 times 0 plus 4y equals 8. Notice 2 times 0 is 0, so we just have to solve 4y equals 8. Division of 4 gives us a y value of 2. 0, 2, we can see, yes, that is the y-intercept. Then we're going to substitute a 0 for the y value. 2x plus 4 times 0 equal to 8. So this time 4 times 0 is eliminated, leaving 2x equals 8. Once we divide by 2, we'll end up with an x value of 4. So 4, 0 is the x-intercept. Now that would be enough to graph the line, but we've got one more substitution just to make sure that our calculations are correct. So let's sub in -2 for x. 2 times -2 plus 4y equals 8. So -4 plus 4y equals 8. Adding 4 to both sides of the equation, 4y is 12. So division of 4 gives us a y value of 3. So hopefully this ordered pair will line up with our others, -2, +3. So that looks pretty good. Let's draw the line and be sure to include arrows on both ends. Our last example, we're given y equals 2/5 x plus 3. So if we're looking specifically for intercepts, notice we need zeros included in the chart, and I've put some other numbers as well. So our first substitution, x value is -5. So isn't it convenient that we're choosing a number to substitute for x that is a multiple of our denominator? That way we ensure that we can reduce and eliminate the fraction. So we now have y equals -2 plus 3. Remember, there is a negative still in that quantity. So that looks like +1. -5, +1 is the first ordered pair. Our next substitution, we're using 0 for x. Y equals 2/5 times 0 plus 3. 0 is always a nice number to substitute because 0 times the fraction also eliminates. Y is now worth 3. 0, 3 is the next ordered pair. Our next substitution, we're using +5. So y will equal 2/5 times +5, add 3. So 5's reduce. We're left with 2 plus 3, which is 5. 5, 5 is our next ordered pair. So those 3 dots look pretty good for lining up. And we have one more substitution because we have not found exactly where this line is going to cross the x-axis yet. So we're about to substitute 0 for the y value. So make sure you're substituting for the right variable. 0 equals 2/5 x plus 3. So I'm going to subtract 3 from both sides to get -3 equals 2/5 x. To eliminate the fraction, I could multiply both sides of the equation now by our denominator of 5. Negative 15 is equal to 2x, because these 5's are reduced. Dividing by 2, it looks like negative 7.5 is equal to x. So I'll plot negative 7.5, 0. So that would be between negative 7 and negative 8. We're ready to draw the line. Don't forget to use the arrows. And there is how you can graph a linear equation by first calculating the x and y intercept.